Feature engineering is really just a fancy term for creating new data. Very often we can help an algorithm build better models by preparing the input data in a way that allows it to detect a clearer signal in the often noisy data set. In machine learning, variables are usually called features, so feature engineering refers to the transformation of variables or the creation of new ones. Typical examples of feature engineering might include rescaling predictor fields, so taking the log of the values in the field, or perhaps turning them into percentiles, replacing missing values, perhaps replacing them based upon the mean of a distribution, or using some sort of imputation or estimation method to estimate what the true value would be, excluding outliers or extreme values in case they might have an undue effect upon the model building process, creating new fields perhaps based on the ratio of one variable to another, so you're combining them together in some fashion, using factor analysis or principal components analysis to create new linear combinations of existing correlated variables, so you're effectively reducing the data down. And lastly, using something like cluster analysis that will create a new variable based on the fact that many cases may be similar to each other. And that's the example that we're going to use in our next demonstration. We're using the same data set as we did in the previous two examples. And again, to refresh your memory, this data set does a pretty good job of predicting the outcome. It's nearly 80% accurate, but there are 66 misclassifications in the test group. That's our testing group. So we can see that there are some false positives and false negatives here. And obviously we want to reduce that number to the minimum and have the largest level of accuracy. So the next method we're going to use to do that is trying to effectively feature engineer the data, and we're going to be using cluster analysis to do that. Cluster analysis allows us to group together records which are similar to each other, and they will create, crucially for us, a new field that tells us what cluster group each of the records belong to. So I've got a method here called the auto cluster method that will allow me to run many different cluster algorithms and lots of different settings. I'm actually going to run 12 different algorithms here, or 12 different permutations, if you like, against this data set, and it's going to result in a model where it sorts the data in order of a measure called the silhouette measure. The silhouette measure is a measure of separation between the groups in the data set. And basically, the larger the number, the better the separation. And what we find is we've asked for a range of different solutions. Some of these are 5-group solutions, some of these are 3-group solutions, and some of them only 2-group solutions. And the one that says it is best is actually this method here, using a 2-step algorithm. It's just come up with 2 cluster groups, and we can see why it's particularly good, because when we color it by, for example, the variable churn, we can see that it actually does a very good job of separating those who churned from those who didn't churn. So the people who are still current customers in the false group are in cluster group 1, a lot of the churners are in cluster group 2. So that would be a very useful variable to use in our prediction, if you like. And if I want to use it, I can simply go into that model itself and then go generate model to palette. It will generate that model to the palette, and then I can connect that model up. So it's effectively going to create a new field for us. Let's just see the field that it creates for us. Just hit edit up here. We can right click on it and say preview the data effectively, so it'll allow me to preview it. You can see it's creating this new field here called $2-step. It's cluster 1, cluster 2. That's effectively our feature engineered, if you like, in there. I can connect that up now and just make sure that that is set as an input, as a variable to be used as a predictor. And then again, I can copy and paste my shade model that I used earlier down here, run it again. It creates a new model for us. We can connect it up, and if we just look inside this new model that's been created, what we notice is it's a very simple model. You see that the most important variable it's using here is the 2-step variable. So it's actually saying I'm going to split this model instantly by whether or not they're in cluster 1 or cluster 2. So that feature that we have engineered that new group that we've created in the data, has become a very important predictor. And when we look at the results of the analysis here, we can see that the error rate now has decreased to only 37 cases from 66 previously, and the accuracy of the model is now 88% as opposed to just under 80% at 79% previously. And that's an example of using feature engineering to boost model accuracy.